All right, guys, third video for today. All of these are one-step equations. This one is going to be talking about one-step equations with fractions in them. And I know we've talked about fractions recently, and we've talked about we're going to use them a lot this year. So hopefully you are ready for that. So some notes on what we're calling reciprocals and solving equations. So we're going to ask about what is the inverse or reciprocal of a fraction such as 2 over 3? When we talk about opposite fractions, what we're really thinking about is that a number is being multiplied by 2 and divided by 3. So the opposite of that would be doing the opposite things. We're going to multiply by 3 and divide by 2. Well, here we have 2 over 3, so the reciprocal would be 3 over 2. All right, so let's practice. Write the reciprocals of these fractions, right? So I have a 1 over 2. When I simplify, when I think about using a reciprocal fraction in an equation, I'm going to use the opposite fraction, right? Inverse means opposite. So what is the opposite fraction? It is 2 over 1. Is 2 over 1 equal to 2? Yes, because 2 divided by 1 is equal to 2. So I could use 2 over 1, or I could use 2 in the equation. 3 over 4 is also a fraction, right? That has, let's make this to focus a little bit better. These numbers are kind of small. That's a little bit better. Okay, 3 over 4 is also a fraction, right? It is 3 divided by 4. And so we have the 4 on the bottom. When we use the opposite, we're going to have the 4 on the top. So 4 over 3. The same is true for 4 over 3 here. The opposite of 4 over 3 is going to be 3 over 4. When we have a negative, it doesn't change. We have a negative 2 over 3. We can have a 3 over a negative 2. Does it matter if the negative is on top or bottom? Not really, but just for the purposes of keeping things the same, I like to just keep it where it is, right? So if this is a 2 on the bottom and a negative 2, and this is a 3 on the top, that came from the 3 on the bottom. 9 over 4, what would that be? Well, that would be 4 over 9. Flip the fraction, and you've got the opposite fraction, the inverse fraction. Negative 5 over 4 is going to be 4 over negative 5. Okay, so pause and try the next couple. Hopefully when you paused, you got that these, right, these two should be negative 1 over 4, should be 4 over negative 1. Remember, when we divide 4 by negative 1, we actually get a negative 4. So we can simplify that one even a little bit further. And then negative 6 over 7, I'm going to have a 7 over negative 6. So all of these fractions are just the opposite fractions, and we're going to use that just like we used opposites with addition and subtraction, or just like we used opposites with multiply and divide. It's still an opposite operation. So let's look at some examples in equations. I have 1/2 times x equals 3. Well, I have a 1/2. So when I take the opposite fraction, what's going to happen? I'm going to say it's 2 over 1. If I do it on one side of the fraction, I have to do it on the other. Sorry, one side of the equation, I have to do it on the other. So I'm going to multiply by 2 over 1. What happens on this side? The 2 divided by 2 is going to cancel. The 1 divided by 1 is going to cancel. And all I'm left with is my x, which is what I always want, to isolate my variable or make my variable by itself. And now you might look at this and say, well, I don't know how to do that in my head. That's hard for me. Well, when I teach you how to do this, you're going to say, oh, that's actually not that hard. We're going to take the big number and we're going to multiply it by the 2 on the top. Well, what is 3 times 2? That's 6, right? So I have 6 divided by the bottom number, divided by 1. Well, what is 6 divided by 1? 6 divided by 1 is still 6. So my answer is 6. And if I wanted to, I could check the equation. 1/2 times 6 is equal to 3. Is 1/2 of 6 3? Yeah, 1/2 times 6 is equal to 3. And if you don't know that in your head, you can use, again, the fraction button in your calculator is this ABC, and you can do 1 over 2, and then parentheses 6 gives you 3. Okay, so 1/2 times 6 gives you 3. And we can check to make sure that my work is correct. 2/3 times x equals 4. I want you guys to try these two. So pause for a second and try those two, and we'll come back in just a minute, and I'll tell you the answers. Okay, so taking a look now, you can see the answers up here. Okay, so the reciprocals were used. See if you got those two answers. If you didn't, you might want to raise your hand at this point and see if you need a little bit more help. Okay, I'm going to go on to the next ones. So the next one, it says, what if the number is negative? Well, it doesn't matter, right? A negative number is still just a number. So I'm still going to multiply by the opposite fraction. Well, in this case, the opposite fraction would be 2 over negative 1. And on the other side, I would do 2 over negative 1. So my negatives 1's cancel and my 2's cancel. And I get x equals 7 times 2 gives me 14 divided by negative 1. Well, what is 14 divided by negative 1? Again, if you're struggling with that, just do it in your calculator. 14 divided by negative 1 equals negative 14. So x equals negative 14. All right, let's look at the next ones. I want you to try these two. They're no different. There just happens to be a negative number in there. Okay, so again, I've written the answers, the work here. Take a second, pause the video, check your work, make sure you got them right. Okay, I know these are seeming like this is strange. These start at 6 and 6 and 10, negative 10, negative 10, just an accident. But these numbers, right, these numbers are using the reciprocals, the opposites, and we're just going to keep doing that in these other examples. We're not doing anything different. The problems just look a little different. That does not mean that they are actually different. They just have the x on the other side in these next ones. So it says, what if the number is on the other side? Well, here's the 14 and here's the 1/2 times x. Well, again, we still have two sides to an equation. So let's look at that fraction side. We want to get the x by itself. So what's the opposite of 1/2? The opposite of 1/2 is 2 over 1. I'm going to multiply by 2 over 1. Okay, so I've got the 1 cancels and the 2 cancels, and the x is on the right side. But it doesn't matter because math can be read from left to right or right to left. So x is equal to 2 times 14, which gives me 28. Change that into a 28, right? And over 1, right? The 2 times 14, 14 times 2 gave me 28. 28 divided by 1 is still going to be 28. And so my x equals 28. So again, I'm using the opposite operation of this fraction, but it's just on the right side of the equation. Okay, so again, do it on both sides, just like you see in my example. All right, last examples. What if the variable or the letter is in the fraction? I know these look different, but this really is the same thing. This really is the same thing as what we might see here, right? 2x over 3 is the same thing as 2 over 3 times x. They look the same in some ways, but they look a little different, and sometimes students get those mixed up. But these two things are saying the same thing. It's 2 times x and then divide by 3. 2 times x and then divide by 3. So in this problem, my fraction is still 2 over 3. So my opposite fraction is 3 over 2. Okay, and my opposite fraction is 3 over 2. I'm going to multiply on both sides by that opposite fraction to get rid of both the multiply and divide at the same time. Now I've got this one, the 3 and the 3 cancel, the 2 and the 2 cancel, and I just get an x equals 24 times 3 over 2. And you might say, I can't do 24 times 3 in my head. That's okay, right? 24 times 3 gives me 72. So I know the top number should be now 72, and I'm still dividing that by the bottom number, which is the 2, right? So divide by this number. Well, 72 divided by 2 gives me 36. Okay, so even if you can't get those in your head, some of them will be bigger numbers and you won't be able to get them in your head. Some of them might end as a fraction, and that's okay. All right, so try the last two here, and I'll show the answers in just a minute. All right, so here you go. The last two are up. Hopefully these answers you're getting them right, you're still doing them right. If you're not, this might be a good time to call me over and have me do a couple examples with you and go through them to make sure that you're getting them. I'm happy to help. Your practice should be the problems, as many as you can do on the back. So a good number of them should get done. I'm sorry, my backside looks kind of crazy because you guys can see that the work bled through to the back on this marker. But try those out, and when you're finished, let me know.